Hey, y'all, let's for exam 2. This is covering chapter 3. So 3-1, 3-2, 3-4, 3-5, 3-6, and 3-7. I will go through this at a pretty rapid pace as much as I can, do a little bit of explaining as I go. Please pause the video if you need to, write down any questions you have for me so that we can go over them before the exam. All right, so let's start. Determine whether the relation is a function. Well, in order for it to be a function, each input can have one and only one output. So 5 only has 2. 6 has 1, but 6 also has 2. So this is not a function. Because 6 cannot have 2 outputs. Okay. 6 cannot have 2 outputs. Right? Evaluate f of -3. Well, this is just saying that when we're going to say x is -3. So that's f of x. So f of -3. And I'm just substituting here. And everywhere there's an x, I'm substituting -3 and simplifying. You have to do what's inside the parentheses first. I'm sorry, inside the absolute value first. 3 times -3 is -9 minus 1. That's equal to -2, the absolute value of -10. Remember, anytime you take the absolute value of anything, it makes it a positive. So we've got -2 parentheses, +10 now. Because it's coming out of the absolute value, it becomes positive. You don't need the positive, I just did that for you. And so my answer is -20. All right, next one. Evaluate the difference quotient. I will be providing you the difference quotient on the exam. If f of x is -2x squared plus 3x, find the difference quotient. So we're going to have to start with the x plus h. So -2. Everywhere there's an x, I leave a space. And I'm going to plug in x plus h. Minus, here's the minus, open a parenthesis and write the entire function again. Write this entire f of x function. -2x squared plus 3x. And all of this is over h. All right, we're going to have to do the quadratic first, x plus h squared. So -2 times x plus h times x plus h. You can use your box method, FOIL, distribute, pick your poison. I'm going to go ahead and distribute my 3. So 3x plus 3h. I'm going to distribute my negative. So +2x squared minus 3x. All right. And all of this is over h. I need space, so I'm just going to do that. I'm going to multiply the two binomials first. You could distribute first, but this is just easier. So -2 times x squared plus xh plus xh is 2xh plus h squared. That's simplified. I'm bringing everything else down. All of this is over h. Now I need to distribute my -2 over my trinomial. -2 times x squared is -2x squared. -2 times +2xh is -4xh. -2 times h squared is -2h squared, bringing everything else down. All right, now we simplify. The 2x squares are gone. I'm left with -4xh minus 2h squared. 3x's are gone, plus 3h. Now, whenever I bring the divided by h, I find it's easier for students if they do it on a per term basis. There's fewer mistakes that are made. And then you just reduce per term. So -4x. This reduces and gives you a 1h, so -2h. And these reduce and give you 3. There is your difference quotient for this one. All right. Is the function 1-to-1? Well, it's definitely a function because it is one of our reciprocal functions. Is it 1-to-1? Yeah, because you will never cross. It's the horizontal line test, right? For 1-to-1, you're never going to touch the same point. So yes, based on the horizontal line test, this is a 1-to-1 function. all right? Because it does say explain. Given the following graph, evaluate the following. F of -2. Let me turn off my light here. There we go. So this means when x is -2, what is the y value on the graph at that point? So find where x is -2 right here. Find that on the graph happening right here. What is my y value there? If I were to write an ordered pair for this, this would be -2 what? And that's the y value. In this case, it's 2. So f of -2 is 2. All right. Looking at f of x is equal to -2. This is the same thing as y. Remember, f of x is y. So when y is -2, find that. Y is -2 down here. What is x? So what would this point be? You know, your y is going to be -2. What would the x value be? In this case, it would be 0. So f of 0 is -2, or you could write x is equal to 0. I would accept either one of those answers. All right, find the domain of the function expressing answers using interval notation. So there's a couple different things happening here. The first thing I see here is we can't have a 0 in our denominator. It's a fraction. So I'm going to take the square root of x minus 4 and set it equal to 0. Well, to not equal to 0. How's that? Because then we can know exactly what it's going to be. So we have to square both sides. X minus 4 can't equal 0. Add 4 to both sides. So x cannot equal 4. Okay. So thinking about my number line, my 4 cannot be a part of it. So it's a circle. The other thing to look at is you can't plug in what for your x on either one of these, honestly. I'll take them one at a time. I'm still at the denominator. I do not want to have a negative in my denominator in the radical inside the square root. So I have to take that x minus 4, and I want my numbers to be greater than or equal to 0. So add 4 to both sides. My x has to be greater than or equal to 4. All right, well, it can't be equal to 4 because I've already said it can't be, but it's going to be the numbers greater than. I'm just starting to do my finding out what things are. The next thing you don't want is you don't want your radical here to have a negative in it as well. So x minus 6 has to be greater than or equal to 0. Gives you a lot of practice. So x has to be greater than or equal to 6. So moving it further over, 4 is not going to be a part of it. 4 to 5 is not going to be part of it. It can only be 6 and greater. So we have to actually move our number line to 6, included, and greater. If we would have plugged in a 5 for x, we would end up with an I in the exponent, and that's no bueno, that's imaginary. So we can't even use 4, between 4 and 6 cannot be used. 6 can be. So my domain is just the domain is from 6 to infinity. Quite a few things there. Find the average rate of change of the function. Now this is on the interval between where x is 1 and x is 2. So what we're doing is we're creating 2 ordered pairs here, where x is 1 in one of them and x is 2 in the other. To find out what the y values are, we're going to have to substitute 1 for x. So f of 1 is, well, -2 over 1 squared, which is -2. All right, f of 2 is -2 over 2 squared, which is -2 over 4, and that's -1/2. Because this is a clean decimal, a terminating decimal, I am totally okay with 0.5, -0.5 instead of -1/2. As of right now, I don't see that being an issue. If it turns out to be an issue, we'll talk. All right, now we have to find the rate of change. Remember, rate of change is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Please, I beg of you, label your points. x1, y1. Your points are xy. So if for this being point 1, that means my sub numbers are x1 and y1. For my next one, it's x sub 2 and y sub 2. Okay, now I'm just going to substitute. Follow this. Make sure you have this in your note card if you don't know it. All right, so y sub 2, I'm going to use my decimal, negative 0.5 minus y sub 1 is negative 2 over x sub 2 is 2 minus x sub 1 is 1. Now let's simplify this. This becomes negative 0.5 plus 2 over 1. Well, that's delightful, which is just what? 1.5. There's your rate of change. Okay. If you have any questions, just let me know. All right. It says determine the intervals on which the function is increasing, decreasing, or constant. Well, remember it's left to right for increasing, decreasing. Constant is when it's flat. So if there are no arrows drawn, assume there are arrows pointing, okay? Assume that it's going to continue on and on unless there's a dot showing you that that's where it ends, which we'll have here in just a minute. So it is constant. That's what we're going to start with, left to right, from negative infinity to negative 3. And it needs a parenthesis. It is increasing left to right. If you're on a roller coaster, you're going up. So it is increasing from negative 3 to 1. And then it is constant again from 1 to infinity. All right, there is your, we don't have any decreasings on this. Now we're going to do composition of functions to find out if they are inverses. We've got the f of x is square root of x plus 2, g of x is 1 over x. So the composition of functions, we'll start with the f of g of x. I'm going to do both, just in case I make a mistake, is taking the f function, and where the x is, I leave a space and I just plug in the 1 over x. Okay. Well, that's not going to clean up very nicely. 1 over x plus 2. That's not going to give me anything that I can do anything with. Let's try the other one, see what it looks like. G of f of x. And that's going to be 1 over the square root of x plus 2. Again, there's nothing I can do to make this turn out to be an x. We would need this to be x, to answer as x, in order for them to be inverses. And I don't foresee that happening in this case. It does not look like they're going to be, there's no way I can simplify them down to make it look like an x. Okay, so no, they are not inverses. This is good because in class, all we had was inverses that worked. Now we're going to find the domain of f of g of x from problem 9. Well, here's problem 9. Here is f of g of x. And they want us to just talk about what's the domain of this. Now, it's not going to be the same problem as before, or on the test, it's the same as this, but to understand what this looks like, well, we don't want what's underneath the radical to be an imaginary number. So to know what the restrictions are, I'm going to take that 1 over x plus 2 and make sure that it is greater than or equal to 0 so that it's not imaginary. And I'm just going to solve for x. So I'm going to move the 2 to the other side. 1 over x is greater than or equal to negative 2. Now we've got an x on the denominator. I can't do anything with that. So we need to make sure that the x moves to the numerator. In order to do that, I just need to multiply both sides by x. These will reduce. I'm left with 1 is greater than or equal to negative 2x. Okay, now I can solve for x. I have to divide both sides by negative 2. I'm going to rewrite it. Remember, when you divide by a negative, your inequality switches. It flips. So I'm going to rewrite this with my x on the left side, just because it makes it easier to see what we're dealing with here. X is going to be greater than or equal to negative 1/2. Again, it's a terminating decimal, so I'm totally cool with 0.5. All right, so, but we need to know what the domain is. The domain needs to be greater than or equal to negative 1/2. So negative 1/2 to positive infinity. And that works. That's your domain for that problem. All right. Oh, No, there's one more thing. Oh gosh, I'm totally missing something, y'all. I'm so sorry. We got a fraction here. I can't have a zero in that denominator. So hold the phone. Let me draw a number line. Negative 1/2, 0, and then that's all I really need. So negative 1/2 can be a part of it, and it's everything to the right. The 0, however, cannot be a part of that because we would have an undefined fraction, and that's no bueno. So what we're going to do instead, this one's wrong, is from negative 1/2 to 0 not included, or 0 not included to positive infinity. That's how we can avoid that situation. Just remove the 0 from our domain. Okay? If you have any questions, just let me know. Let's go to the next part. It says, explain in words the change from the original toolkit function. Here's your quadratic, your basic toolkit function. And we've only got a couple of things happening here, 3 actually. This is going to get a reflection. So we have a reflection, a vertical reflection. Okay, that's what the negative out front is. If your A is negative, that's what happens. We also have our horizontal shift, because remember, this should be, if you were looking at it, you've got A, X minus H plus K. So our 2 is positive. A negative's already built into the situation. So if we have a positive, this means this is X minus negative 2 in order to look like this. So my H is negative 2, which means we have a horizontal shift of to the left 2. That's another thing that's happening. One final thing is we have a vertical shift. This one you don't have to flip the sign on. We have a vertical shift, and this one's down 1. All right, that's what's happening with that guy. Next one, we've got a quadratic. It says, write the equation of the standard function represented by the graph below. Well, this is just your basic quadratic. So I'm going to just do an A. Let's see if we've got any, it looks like we have some shifting here. X minus H squared plus K. This is just our basic, what we're starting off with. I don't know what my A is yet. So this is going to help me find out what my quadratic is. All right. Well, our basic toolkit function would have the vertex here at 0. But in our case, it's shifted over 2. So that means I shifted left 2, which means my H is going to be a negative 2. We just found that out. And the last one was the same way. We'll have to solve for A. All right, K also has us shifting down negative 1, so minus 1. So that takes care of my horizontal shift and my vertical shift. I am not going to give you a horizontal stretch or compression. This is what you're going to have to deal with exactly on this exam. You'll have to find your shifting if there's anything happening, as well as possibly a vertical reflection or compression. So this is not going to be a reflection because it's not flipped. The quadratic is not flipped. So it's not a negative A, but we can solve for what it is after I clean this up. I'm just tightening this up. This is X plus 2 squared minus 1. All right, so now to find my A, I can choose any point except for the vertex to find out what my A is. And I am kind of liking this 0, negative 3 or 0, negative 1. I'll do 0, negative 3. All right, so this is what my X is, and this is my Y or my F of X. Where my F of X is, I'm just going to substitute the Y, the negative 3. I'm solving for A. X is 0. Okay. 2 squared is 4. I'm going to add 1 to both sides. Divide both sides by 4. And A is equal to negative 1/2. Please reduce. Okay. So now we just need to rewrite our function. A is -1/2. X plus 2 squared minus 1. Okay. Let's look at the next one. Determine whether the function below is odd, even, odd, or neither. So the first thing we need to do is substitute -x for x. All right, I'm going to simplify this. This is -1/x minus 3x. And that does not look like the original function. And if it did, it would be even, but it is not, so it is not even. Now what we need to do is factor out a negative from all the terms. Now I ask myself, does this look like a negative of the original function? And yes, it does. So this is an odd function. Because h of -x is equal to the negative of h of x. And that's why. We substituted -x in for x, and what we got back was negative of the original. And so that's why it's the odd function. All right. Find the inverse for the function. F of x is x over x plus 2. All right. So first thing we have to do is substitute y for f of x. X over x plus 2. Now we switch places. Where there's a y, we're going to put an x. And everywhere there's an x, I'm going to put a y. All right. To get rid of get the y out of the denominator, we're going to have to multiply both sides by y plus 2, just to get it out of there. All right. It's gone from here now. Distribute your x over the binomial. You've got xy plus 2x is equal to y. I need every term that has a y in it on one side. So I'm going to subtract this y. And I have xy minus y. I want to move the 2x over as well. So I'm going to subtract 2x from both sides. All right. Now I have y's in common. So I need to factor out a y. And divide both sides by x minus 1. This reduces, and I'm going to come up here. Y is equal to -2x over x minus 1. All right, last piece of this is I didn't ask for y, I'm asking for the inverse. So just substitute the inverse of x, the inverse of f, and rewrite your new inverse. And that's it. All right, given f of x is x cubed minus 5 and g of x is the cube root of x plus 5, find the compositions of them. What does the answer tell us about the relationship between the two? So we're finding compositions. All right, f of g. And if you prefer to write it like a fog of x, it's totally your choice. It's the same thing. That just means that we're taking the f function everywhere there's an x. I'm shoving in the g function. And then for the g of x, the g of f of x, we take the g function, the cube root, and where the x is, I'm going to put in the f function plus 5. So this is x cubed minus 5. All right, I'm going to simplify this side first. Cube root cubed, well, those cancel each other out. So I've got x plus 5 minus 5, and that's just equal to x. These are gone. Cube root of, I have to do what's underneath the radical first. So this is equal to the cube root of the 5's cancel each other out. So I'm left with x cubed. Cube root of x cubed is just x. So these are inverses. So what does the relationship tell us? We found the answers for A and B. They are inverses. We didn't have them earlier, but we got them now. All right, determine whether the function is 1-to-1. You must explain your answer to receive any points. So this is just the reciprocal function, and you can put this on your calculator. The reason I did this is so you would use your graphing calculator and make sure you understand how to use it. to find out whether or not something's one-to-one. If you see a graph like this, these lines are never going to, the points are never going to hit the same point. They're going to be a one-to-one function, all right? They wouldn't be if it was 1 over x squared. So that's the reciprocal squared. But with this one, yes, one-to-one passes vertical line test and horizontal line test. I'm totally cool with HLT and VLT. All right. This is the one I warned y'all about. There's going to be one on the exam. So if f of 5 is 2, find the inverse of 2. Well, if this is 5, 2, the inverse is going to be 2, 5. So the inverse of 2 is 5. Okay. What's in the domain of the original is in the range of the inverse and vice versa. Okay. Last page. And this one is not going to be helpful with your graphing calculator. And there's a reason for that. I want you to show me what this is actually doing. So we're going to take this guy and move it over here. What I like to do is, this is why I tell y'all to use pencils. I like to draw the original one first. So -2, 0, -2. It depends on how you want to do this. I'm just going to put it here. And then I've got 0, 2, and 0, 2, 0. All right, there's the original one, if I drew the little hoop. But we're being given the directions to create a transformation that has x minus 1 minus 2. Remember, this is based off of the x minus h plus k. In this case, our horizontal shift is 1. We're going to shift 1 to the right because it is positive. All right. This one is our vertical shift, and we're going to shift down 2. So I'm going to take each one of these points, shift 1 to the left, shift 1 to the right, and then down 2. 1 to the right, down 2. Place my point. 1 to the right, down 2. 1 to the right, down 2. So now I can erase my previous ones and draw. Of course, you could choose the scale you want. I just stuck with the lines being each one. And there's my drawing representation. Okay. It's just a sketch, nothing exciting. Notice one thing I want you to notice. Notice it has dots. It does end. It's not continuing on and on. So that's one of the things I want you to notice on that. All right, write the equation for the absolute value function represented below. All right, well, same thing. F of x is ax minus h plus k. And the x minus h happens inside the absolute value and then plus k. Hopefully you know that the toolkit function is the absolute value of x, because then we can expand on that. Again, the only thing you're going to have to deal with is vertical and horizontal shifts, as well as finding whether it's a reflection, which this one is not, or what the A is if it's not 1. Okay, so to do that, I need to know that my original toolkit function looks like this. There's other ways to do this too, but we haven't learned that yet. So knowing that that's the original toolkit function, I can see that it has just shifted, not up or down, so I don't have to worry about my vertical shift. I only need to worry about my horizontal shift, and it's shifted 1, 2, 3 to the right. So I'm going to have f of x is a, and then x minus 3, because it shifted 3 to the right. Now I need to find my a. There's no k because it's not shifting up or down. To find my a, I like to replace my f of x with y, and now choose any other point on the graph, with the exception of the vertex. Never, never, never choose the vertex. It's going to give you a 1 for a. and that's not going to be helpful. I love the y-intercept. It looks really nice here. It's got a 0, so that makes me happy. So I'm going to use 0, 3. Where the y is, because this is xy, I'm going to substitute 3 for y. I'm looking for a. My x is 0. All right, now we're going to just solve for a. Absolute value of -3, because that's 0 minus 3 is -3. Won't miss any steps here. So absolute value of -3 is +3. Divide both sides by 3. And a is 1. So I didn't need to worry about that, but you never know. You never know. So all I need to do to rewrite this for my function is, well, it's 1. So it's just absolute value of x minus 3. There you go. All right. Last one. Find the local extrema for the function on the interval. So if you just look at this, you're going to think you know what I'm doing. But unless you look at the interval, you're not. Okay. So I don't want you to just say what the highest point here is. One, we don't know what the max extrema is, which is why I'm asking for the local. All right. Local extrema is going to be your local max and your local min, but we want it only on the interval from 0 to 4. So from here to here only, I want you to only look at this. If we're only looking at this interval, what is our local min and our local max? We've got a local max, and that's happening at the y value at 5. I kind of blew through that. Local max of 5 at x equals 1. Okay. We also have a local min or minimum of 1 at x equals 3. Okay. Yes, there are other local maxes and mins happening, but I'm not asking about those. I'm strictly asking based on the interval. All right, that's it. If you have any more questions, let me know.